Today in pre-cal we started talking about reference angles, and I've recopied this definition down for you just so you don't have to watch me write it. Instead, I'm going to spend my time explaining it to you. A reference angle, the reason this is important is this helps us to start to memorize some things on the unit circle, understand and utilize where those things are coming from. So the definition is let theta be an angle in standard position. So theta is the angle. Standard position, remember, just means that it starts at 0 and then goes to wherever it's going to stop. Its reference angle is the acute angle, so acute's less than 90 degrees. Theta naught, or theta prime, formed by the terminal side. Terminal is where the original angle ends of theta and the x-axis. Let's look at what that means in practice. If I take an angle in the second quadrant, and I draw it here, this is my initial side, this is my terminal side. There's my angle theta. That should all be review. Now, I want to figure out what my reference angle is. That would be this angle here. And the reason that this is my reference is it is between my terminal and the closest x-axis. The reason I want to see this is that if I can figure out what this is, it's going to help me figure out my sine, cosine, and the following trig functions. To do that, my theta naught, the way I'd figure that out, if I knew this angle and I want this one, and I know the whole top is 180, I can either do pi minus theta, that's radians, or 180 minus theta, that'd be in degrees. What about if I'm talking about one in the third quadrant? So that would be different, an angle in the third quadrant. Go ahead and draw that in. That's our theta. The closest distance back would be the opposite way. That'd be theta naught. To figure that out, if I have this distance, I could find my theta naught by doing theta minus pi or theta minus 180. Because if I take this top distance, I would get this distance in between right here. So as you can already see, it's different depending on what quadrant. So we've done quadrants 2 and 3. In a second, we're going to do quadrant 4, but let me explain why we did not do quadrant 1. If we're talking about an angle in quadrant 1, it already would be an acute angle, so between 0 and 90 degrees, and its reference would just be the original angle. That's why we aren't going to look at that one. The final one, what to do if it's in quadrant 4, go ahead and draw that angle in, and we're going all the way around theta. This distance in between, this theta naught, is the distance to the closest x-axis. To find theta naught, if we're talking about radians, a full distance around, again, would be 2 pi. So 2 pi minus theta would give me my theta naught, or 360 minus pi would give me that value. Now, let's look at that in practice. If I have the angle 300 degrees, I know that that's in the fourth quadrant. So to find the reference angle, I'm going to do 360 minus 300, and that reference angle is 60 degrees. The value in that, again, is knowing that if I'm in the fourth quadrant, my x value is going to be positive, my y value is going to be negative, and at 60 degrees, my x value is always square root of 1/2, and my y value is always square root of 3 over 2. So then if I can just apply my signs, I already know what that piece looks like without drawing the whole unit circle. Let's try another one. If I'm talking about negative degrees, I have to think about going counterclockwise if I was to count. So it's going to be going this direction. It'll end up somewhere here in the third quadrant. But to figure that out, it'll probably be easiest to find a coterminal angle by adding 360 degrees. That'd be 225 degrees. And if I do that, we know it's here. 225 minus 180 would be 45 degrees. And so now we know that negative 135 performs the same way as 45 degrees, and we can easily figure out our trig functions from there. The assignment today is A3, and it's this assignment here, which is a worksheet. What I want you to do is try to do this some without your unit circle and then some using your unit circle, depending on how comfortable you are. You're going to go all the way down the list and do the radians. So 0, 30 degrees is the same as pi over 6, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2, and on and on and on. Again, the more you can do without looking at your unit circle, the better, but you do want to be accurate here. Then for sine, remember sine is our y values. So our y value at 0 is 0. Our y value at 30 degrees is 1/2. At 45, it's root 2 over 2. At 60, it's root 3 over 2. And at 90, it's 1. Okay, we could do our cosine is 1. Square root of 3 over 2. Remember, our cosine is our x value. Root 2 over 2, 1/2, and 0. And again, you can go all the way down. Tangent is y over x. I'm not going to continue doing this full part of the chart, but I'll do these first two with you. 0 over 1 is 0. 1/2 over root 3 over 2. Remember that we just do the top, so 1 over root 3. And if I rationalize that, that's root 3 over 3. And continue on from there. Our cosecant is our sine flipped, that's 1 over y, or just sine flipped. 1 over 0, of course, because I can't flip 0, is undefined. 1/2 flipped is just 2. Our secant is 1 over x, so 1 over 1 would be 1. This one flipped would be 2 over root 3, which is 2 root 3 over 3 if I simplify. And then finally our cotangent is our x over our y. So if I did 1 over 0, this would also be undefined. And here I would do root 3 over 1, which is root 3. Or I could just flip this one right here. Now, as you move through, watch your signs. Be sure to notice as many patterns as you can. Most of these things should look very similar as you work your way through. Good luck.